Sound Part 2 Sound Wave. In the previous video, we got an introduction to production and propagation of sound. In this video, we will learn about sound waves. Earlier, we studied that sound is a mechanical wave and it needs a material medium to travel. Now, let us conduct a simple experiment to understand the medium of sound better. Take an airtight glass bell jar and an electric bell. A vacuum pump is connected at the bottom of the bell jar. Suspend the electric bell inside the bell jar as shown in this image. Then press the switch and you will be able to hear the sound of the bell. Now start the vacuum pump. You will notice that the sound of the bell gradually becomes fainter. What do you think will happen when all the air is sucked out of the jar by the pump? Can you still hear the sound of the bell? Now, let us perform another activity to understand the sound wave. Take a slinky and ask your friend to hold one of its ends. You hold the other end of the slinky. Stretch the slinky and then give a sharp push towards your friend. What did you notice? Some regions of the coils will become closer, while some regions of the coils will become further apart. The closer regions of the coil are compressions, and the further regions of the coil are rarefactions. Now, compare the propagation of disturbance in the slinky with the propagation of sound in a medium. These waves are termed as longitudinal waves. In these waves, the particles do not move from one place to another. They simply oscillate back and forth about their position of rest. The sound waves also travel like this. So, sound waves are longitudinal waves. There exists another type of wave, known as transverse wave. The particles in a transverse wave do not move back and forth, but they move up and down about their mean position in a direction perpendicular to the direction of propagation of the wave. One example of a transverse wave is light. But in light, the oscillations are not of the medium particles or pressure or their density, as it is not a mechanical wave. Now, let us understand the characteristics of a sound wave. A sound wave can be described with the help of its frequency, amplitude, and speed. Have a look at these images of a sound wave. It shows the variation in density and pressure of a sound wave at a given time with distance. The regions where particles are crowded are compressions. They are represented by the upper portion of the curve. The peak of the curve represents the maximum compression. Therefore, density and pressure are high in compressions. The regions of low pressure, where particles are spread apart, are rarefactions. They are represented by the lower portion of the curve. The peak of the curve is called crest, and the valley is called trough of a sound wave. The distance between two consecutive compressions or two consecutive rarefactions is called wavelength. Wavelength is denoted by lambda. Its SI unit is meter. Whenever sound travels through a medium, the density of the medium changes from maximum value to minimum value, and then again to maximum value, making one complete oscillation. The number of oscillations per unit time is the frequency of the sound wave. Frequency is denoted by nu. The SI unit of frequency is Hertz. It is named after Heinrich Rudolf Hertz, who laid the foundation for future development of radio, telephone, telegraph, and even television. The time taken by one complete oscillation is the time period of the sound wave, which is denoted by T. The frequency and time period are related as nu is equal to 1 by T. Now, suppose a violin and a flute are played at the same time. Both the sounds travel through the same medium, air, and reach your ears. But why do you hear two different sounds? It is because of the different characteristics of the two sounds. One of those characteristics is the pitch of the sound. The way the frequency of a sound is interpreted by the brain is called its pitch. The faster the vibration, the higher the frequency, and the higher is the pitch of the sound. Therefore, a high-pitched sound corresponds to more number of compression and rarefactions passing through a fixed point per unit time. Objects of different sizes and conditions vibrate at different frequencies to produce sounds of different pitches. Now, when we tap a table lightly, we hear a soft sound. While when we hit a table hard, we hear a loud sound. Why do you think this happens? Think for a while. It happens due to the amplitude of the sound wave. The magnitude of the maximum disturbance in the medium on either side of the mean value is called the amplitude of the wave. It is denoted by A. For sound, the unit of amplitude will be that of pressure or density. As a sound travels from a source, its amplitude and loudness decreases. A louder sound can travel to a larger distance than a soft sound. The quality of a sound is the feature which helps us to differentiate between two sounds with the same pitch and loudness. A sound of a single frequency is called a tone, and a sound which is a combination of several frequencies is called a note, which is pleasant to our ears. Noise is the unpleasant sound which we hear, while music is pleasant and of a rich quality. In this video, we learned about sound waves. In the next video, we will learn about the speed of sound.